Okay, so now the last one I'm going to do is 2016 10A. So this one says distinguish between a strong acid and a weak acid. Okay, so first of all, sorry, now I keep moving that, girls. So a strong acid fully dissociates in solution. Fully dissociates in solution, and remember we said it was and is a good proton donor. A weak acid does not, so a weak acid does not fully dissociate. In solution, and is a poor proton donor. Okay, so that's the first part. Now calculate, then it says this, by the way, this is 2016, I'm not writing that down. So this is 2016, girls. This is this is 10A, question 10A. This is part 1, strong acid and weak acid. Part 2 is calculate the molarity of a sulfuric acid solution that has a pH of 2. Okay, so we're looking for the hydrogen ion concentration of the sulfuric acid solution. Okay, so the pH is equal to minus the log of the H plus ion solution concentration. We have pH of 2 this time, so that's minus the log of the H plus ion concentration. If I anti-log minus 2, that will give me 0.01 is equal to the hydrogen ion concentration. Now, because it's sulfuric acid, I'm going to be really careful. So again, write the dissociation constant afterwards. So 2H pluses giving you SO4 2 minus. So that means that if I have 0.01 moles of H pluses, I had half that solution, so I need to divide that by 2 to give me the concentration of the original sulfuric acid solution. And when I do that, I get 0.005 molar. That was the answer I was looking for there. Then it says the acid's dissociation constant for a weak monobasic acid is 1.8 by 10 to the minus 4. Calculate the molarity of a solution of this acid that also has a pH of 2. Okay, so this is another acid, it's the weak acid. So again, a weak acid means it doesn't fully dissociate in solution. I'm going to pay attention to the fact that they told me it was a monobasic acid, a monobasic weak acid. That means only one H plus is donated. So for any monobasic acid, that will give me a H plus an A minus. So that just means that 1 mole of H plus will give me 1 mole of H 1 mole of HA will give me 1 mole of H pluses. Okay, so what was my pH? pH for a weak acid, remember, is minus the log of the square root of the Ka by molarity. pH, I'm told, is 2. So 2 is equal to minus the log of the Ka by molarity, square root of that. I'm told what the Ka is. In the question it says it's 1.8 by 10 to the minus 4. So 1.8 by 10 to the minus 4 multiplied by the molarity is the Ka. If I get the anti-log of minus 2, that will give me 0.01. That's equal to 1.8 by 10 to the minus 4 multiplied by molarity, square root of all of that. Let's square both sides to get rid of that square root, and this becomes 1 by 10 to the minus 4 is equal to 1.8 by 10 to the minus 4 on that side, multiplied by molarity. So I'll divide all the way across by 1.8 by 10 to the minus 4, and that will give me 0.5556 is equal to the molarity. So that's going to be my answer, my final answer for that part. Now, the last bit says, define Kw, the ionic product of water. Okay, so the third part would be Kw is equal to H plus concentration by OH minus concentration. The value for Kw at 59 degrees is 9 by 10 to the minus 14. What is the hydrogen ion concentration in pure water at this temperature? Okay, so I know what the Kw is. I'm told that the Kw in this case is 9 by 10 to the minus 14. And I know, remember, that the Kw is equal to the H plus concentration squared, because the H plus concentration is equal to the OH minus concentration. I know that already. So I can say that this 9 by 10 to the minus 14 is really equal to the H plus concentration squared. So if I square both sides, that will give me 3 by 10 to the minus 7 is equal to the H plus ion concentration. That's what I must have.